you here in my room. I want you here. Now we're gonna be face to face, and I'll lay right down in my favorite place. And now I wanna be your dog. And now I wanna be your dog. And now I wanna be your dog. Well, come on. Now I'm ready to close my eyes. But now I'm ready to close my mind. And now I'm ready to feel your hand. To lose my heart on the burning sand. And now I wanna be your dog. And now I wanna be your dog. And now I wanna be your dog. Well, come on. Woo.
All right, so remember that your first assignment is due tomorrow at midnight, by midnight, 1 second before midnight. And then your lab 3 is due tonight by midnight. So we'll be helping, we'll have yet another help session, lab session upstairs after this. But to continue and possibly conclude and then transition into object-oriented programming, I wanted to finish up this demonstration with the books and the authors and stuff like that. And our last report here was where we wanted to find all the books by Terry Pratchett. And so what we're going to do is we're going to use binary search. Binary search requires that you have a key, right? So I want to search for a particular author. Well, how am I modeling an author in an object-oriented programming manner? It's with a person class, right? So I'm going to create a, let's go back over here. I'm going to create a key for Terry. And now what I need to do is I need to search that collection of books for a book by that author. So collections.binary search. Right? Remember that we can give it a collection, the things that we want to sort through, so all my books here. And then we can provide it the key that we're trying to search for. There we go. Now the problem here is that it's not going to compile. We've got apples and oranges. So what is the collection that I'm searching? It's a list of books, right? What is the key that I'm providing? A person. So is a person a book? Is a book a person? Definitely not. So what we need to do is we need to create apples to apples, oranges to oranges. The key that I need is an actual book, B, book key, I'll say. All right, key is equal to new book. Now the problem here is that the only constructor that I've written so far is the one that takes an ID, a title, an author, an ISBN, a rating, and a year, right? But I don't have all those things. If I had all those things, I would already have a book by Terry Pratchett. I want a book by Terry Pratchett, and all I have is the author here. So what I'd really like to do is a way to create a book where I specify only the author, right? Well, if that's what you want, go ahead and give it to yourself. Remember that you can have that you can generate constructors using fields. I'm just going to go ahead and deselect all. I want I want a constructor that generates one for just the author. I've got now two constructors. I've got two ways of constructing a book. One with all the data, one with only part of the data. All right. Now I can come over here to book demo, and you see that line 90 is now compiling. I can create a book. It's not a real book. It's a key that I'm going to be using in order to search all these books. And let me go ahead and replace this now with my book key. Right. Remember that it returns an integer index at which you found it. And so we can go ahead and print this out, system.out. We're not done. Println found book B, books.get at index at plus at index, and then I'll go ahead and concatenate the index. There we go. Okay. All right. So why is my binary search here not working? Well, we can hover over it and say, I don't know anything. These are books, and that's the book key. But does Java know how to? Have I told Java how to find that needle in the haystack? We've got apples to apples, oranges to oranges, books to books. Does it know how to compare those things? So if you look back on what we did before on Tuesday, I think it was, when we created this person class, we made it comparable. That person is comparable to that person, right? But do we have the same thing for book over here? Nope. So I've got a book A and a book B. How do I know that they're equal, right? There's nothing in here that tells me. So I could do the same pattern, right? I could go ahead and implement comparable book, right? But the problem with that is that locks me into one way of comparing a book. How do you know that that book is equal to that book? Is it because their IDs are the same? Right? Is it because the authors are the same? Right? Is it because the ISBNs are the same? Right? So if you've got many pieces of data here and no clear way of comparing them, then probably don't want to go that way. Instead, we go back to what we were using before, comparators. Here's a comparator that compares books by author and then by year. That's not what we want though. What do we want? Just by author. All right, so by author, not then by the year. Comparator, comparing the book's author, and then I don't need to reverse it, so I'll just go ahead and end it right there. Right. Book by author. And I will go ahead and put this in. There. Now you can binary search it, your collection of books, with your book key using this comparator for books that compares them by author. Right? All of this is encoded in my variable names too, right? It's really easy to read because I'm binary searching my books using my book key, using a comparator for books by author, right? A nice English flow there, right? So let's go ahead and find out if it works now. Oops, it doesn't, right? It didn't find any books by Terry Pratchett. Why? How do I know that? Because it returned an index that is negative. And when I've got a negative index, that means it was unsuccessful. But I can guarantee you that there are books by Terry Pratchett. Find Pratchett. There's one. Johnny and the Bomb. In fact, I can guarantee you that there are 5 books there. So what was my mistake here? If you're going to use binary search, what is the assumption that you have to operate under? It's already sorted. When was the last time we sorted this thing? Using this. Compare books by author, then by year. Right? Is that how I'm searching for it down here? Nope. So if you're going to use binary search, the first thing you need to do is sort it by the same criteria as that you're going to search it with. Right, there we go. There we go. It's sort, and now we should be able to find at least one of those books. Found the book Only You Can Save Mankind by Terry Pratchett at index 74. Right. Now it's a successful search. That's one way of doing it. Here's an even better way of doing it. Right? We want to do some better data processing here using smart data structures. right? I want to not just find one book by Terry Pratchett, a book by Terry Pratchett. I want to find all 5 of them. But I don't want to solve that problem just for one author. I want to solve that problem for all authors. I want to map an author to a list of the books that they've written using a map. Once again, a map is a key value pairing. The key in this case is going to be an author. What's the value? A list of books. And how do we do that in Java? List of books. Right? And I'll call this author map. Right, is equal to new hash map. There we go. Right. And oh, not author. Sorry. How am I representing an author? A person. There we go. And I need to import these. Import. Import. There we go. All right. Now I need to build that map. Okay. Let me outline this first. As a first step, or first try, right? Try getting all of the unique authors, right? Then for each author, right, you can find their books, right, and place them in a map, ... right? Well, okay, I'm going to save that for the sequel down there, right? Let's go ahead and try this first here. What I want to do is I want to find all of the unique authors, okay? When I say unique, what kind of smart data structure should that be, should come to your mind and your head? Unique, no duplicates. Does a list allow duplicates? Yep. So what's the other one that does not allow duplicates? A set of persons. Let me call it authors, all right? Is equal to new hash set, right? All right. Author, do I already have, no, I don't have a variable named authors yet. All right, so let's go ahead and import that, and we're good. All right? So now there's nothing in there yet, but what I'm going to do is I'm going to iterate for each book, right? Place the author into the set, right? ... Right? So that's pretty straightforward. For book B in the set, list books, right? I'm going to say authors.add b.getAuthor. Right? There. System.out.println. Actually, no, it's not going to look very pretty. Let's go ahead and do it like this. For person P in the collection authors, right? I'm going to go ahead and print them out one to a line. System.out.println P. Now, do I need to worry about formatting here? Right? How is that person going to get printed? Right? Didn't we already do that? By creating a toString method. By designing this object, in fact, if we had started from scratch, designed these objects first, and gave them all of these bells and whistles, right? Everything would have been way more straightforward. Right? If the design came first, and we had a toString method, a compare method, constructors, et cetera, right? Then we don't need to worry about those details over here. It gets printed. How do we know it gets printed? Well, that's the person class's responsibility. Right? Now let's see if this worked. Okay, there we go. I see Terry Pratchett way down here at the bottom. Right? Do you see Terry Pratchett anywhere else? Yeah, where? Okay, I'll do a search. Pratchett. There we go. There's 1, 2, 3, 4, and there's the books. I'll tell you right now that he's probably going to appear 5 times. I can't go backwards. Oh, there we go, backwards. There we go. And now go forwards. So find 1, 2, 3, 4, 5. He appears 5 times. Does that sound like a set to you? Doesn't to me. So did we screw up and did I tell you wrong that sets don't allow duplicates? Nope. The problem is that a set assumes that an author is uniquely identified. In other words, a person is uniquely identified. Right? Now, we do have a way of comparing an author. If the last names and the first names match, then that means that they're the same author. Right? What's another way that I could uniquely represent a person? Let's think about this more broadly. Right? Let's go back up here, sorry. Right? So, for example, if they were a UNO student, right? How is a UNO student uniquely identified?
Anybody who
an NUID, right? Anybody in the NU system, right? Let's think more broadly about that, though. What about usually somebody in the United States? Social Security number or a tax ID number, right? What's another way that we can do this? We can generate our own, right? For example, this book data that we were playing around with, remember that this ID and is automatically created by the Goodreads.com website? Well, if it were talking about a book instead of a person, ISBN. What's another way that we could uniquely identify a person, for example, in your homework for tomorrow? How is a person uniquely identified in that data set? UUID. A universally unique ID. Those are cryptographically generated using hash functions, such that the probability that any two computers for the next billion years at any point randomly generate the same two IDs is extremely small, right? That's how cryptography works. Right? The collisions are extreme. The probability of a collision is extremely small. So, but I don't have that data here, right? So what I need to do is I need to tell Java, okay, well that person and that person, Terry Pratchett and Terry Pratchett, those aren't two people. That's the same person based on the first name and the last name. And compare to is not going to be enough. I need something else. So I'm going to go up here to source and generate a hash code and an equals method. Right? The hash code is so that it can be used in hash-based data structures, such as a hash set, a hash map. Right? We'll talk about those. You'll talk about those maybe in Computer Science 3 when you get to data structures more deeply. But for us, what else do we? Let's go back over here. The equals method is what's used by sets. How do I know? Okay, so I've got a bunch of authors already in there. Here's a new author that I'm about to add to the set. How do I know that it's a duplicate or not? What I do is I ask, is it equal to any of those other objects? Right? This is Java now doing it for you, right? Under the hood. And it takes this other object and blah, blah, blah. Don't worry about most of this stuff. But if it's if the first names match, right, they're equal, and the last names match, right, then it returns, yes, these two things are equal. And now we won't have a duplicate over here. Let's go back over here to the book demo, run this again one more time, and let's search for Terry Pratchett. And he's only going to, he's going to show up there on the other lists, but down here on the author list, he's only going to show up once, right? Not 5 times. Okay? So the equals and the hash code method. Now, you saw how I did that, right? I just went up to source and I generated the equals and the hash code method. Let it take care of it for you, right? It's kind of complex, so just let it take care of it for you. If I had a UUID, I wouldn't rely on the first name, last name. I would just say UUID instead, right? You can do that when you generate it, by the way. If you generate equals and hash code, you can, okay. Let's go ahead and get rid of it and save it. So generate equals and hash code. You can select a subset of the data that it's based on. I only want it to be based on the last name. Now, Smith and Smith, even though it's Jane and John Smith, they're going to end up being the same, and that's not what I want. Right? I want it to be based on the entire state of the object. Equals and hash code. Okay? Awesome. So now I've got all the authors. Maybe I want to go over to the book and identify the criteria for 2 books being equal, but I won't go that far. Right? Again, it's just generating code. Okay, now that I've got all the authors, I could find their books and place them in a map. It would look something like this. For each author, ... for each book, right? If the book's author is equal to the author, right? Author A, let's give it a label. So book B, if B's author is equal to A, then add it to A's list. There we go, ... So just a pseudocode outline there, right? That should be giving you red flags though, right? Now, our data is not that big. We've only got 100 books, and we've got fewer, maybe 50 authors or something, right? But think about these for loops. For each A, for each B. What if these weren't books? What if instead they were patient data? Or what if these were big data, right? As in like, say that there are 1 million authors here. Right? I was looking at the full Goodreads database, and say that there are 1 million books here, right? Or maybe 10 million books. 10 million books. There we go. So how many operations am I going to be doing on line 121? 10 million times 1 million is how many millions? Many, many millions. We call them trillions, 10 trillion, right? This would end up being 10 trillion operations, ... Not something you want to do, and if you're doing something naive like this with nested for loops on the grader, it will not run. It'll take hours, days, maybe a week to run, and it'll time out after 5 minutes. So if you're you've got 2 files, and there will be 1 million elements over here, or maybe 10 million elements over here, and there will be 10 million elements over here. 100 million operations, or 100 trillion operations, that ain't happening. Right? So let's rethink this. Right? I'm not going to go for each author for each book. What I'm going to do is, for each book, right, I'm going to use the map, the smart data structure. Right? Get the list of the B's, here, let me label these. For each book B, get the list of B's authors books. There we go. And then add the book B to this list. Right? That looks much shallower. Do you see two nested for loops there now? No. All I see is 1 book. Now, if there are 1 million books, we still have to do 1 million operations, but that's way better than 100 trillion or 10 trillion or 1 trillion. Right? We are going to be much, much faster with this. All right, so let's start translating this. For book B in books. Right? Well, how do I get the author first? Right? Person author is equal to B dot get author. Right? Now I've got the author in my hand. That's going to be the key, right? Remember my map up here, the author map? I've got the person, and it maps to a list of books. So, and let me move this stuff over here, right? So, 1A, get the author, ... B, get the list of books by that author. Right? All right, and how do I do that? Well, I ask the map, list of books, authors, books, right, is equal to, I called it author map dot get the author. Right? So, again, smart data structures, dumb code are a lot better than the other way around. Putting stuff in and taking stuff out, it automatically looks that up for me and gives me this list of books by that author, that person. Right? And by the way, this is only possible because I already did the grunt work of creating and designing this object properly with equals and hash code and compare to, et cetera, et cetera. Right? Okay. A, B, now C, right? Let's add the book to the list. Authors, books, dot add B. There. Right? And I can reiterate over it down here. We're still not done. But what I can do is I can iterate over for each author, right? For each author, print nicely all their books. ... Right? So for person, author, in the collection, authors, or the key set, if I want to do this for the with respect to the map itself, right? Whatever the map was called, what was it? Author map, right? Dot key set. There we go. That gives me the set of keys. So for each author, I can get their books just like I did up here, and I can print them out. Right? I'm going to first print the author, system.out.println, the author, right? And then I will go into another for loop for book B in not the entire list of books, but that particular author's books. System.out.println, and then I'll tab over and concatenate the book. Okay? That's going to print it out really nicely. It's going to print it out with the author's last name, comma, first name, and then tabbed in are going to be a list of all of their books. Okay? It's not going to work though because we still have a problem up here. Let's go ahead and run this. Uh-oh. We cannot invoke add because author's book is null. It's happening on line 124, right? So now think about this operation here. Say that this is the first time I've seen Terry Pratchett, right? So I've got the author of that book, Johnny and the Bomb or whatever, right? Have we actually given them a list at any point yet? This is the first time we've seen this author. Do they have a list? No. So as a consequence, this author's book is going to be null because the key and the value have not been placed into this map yet. So we need to put it there. If author's books is equal to null, then we need to instantiate it. We need to create it. Author's books is equal to new array list. Right? And then what we can do is we can put it into the map. Author map.put, not Terry, but the author will map to the author's books. There. I need to import this. Right? All right, so again, let's walk through this one more time. For each book, I've got the author. I try to get their books. But if their books have not been instantiated, this is the first time I've seen this author. So I go ahead and create the brand new list and map the author to their books, which is empty. Right? This is an empty list. But that's okay because down here, I still have a reference to it and I add the book. Right? Now this should run. Right? There we go. All right, so H.G. Wells and all his 3 books. Ian Fleming, we've got 4 James Bond books there. Where's Terry Pratchett? There's Terry Pratchett. And we've got 5 of his books there. Right? Now, this is much more powerful way of representing data because what if I wanted reports of how many authors do I have that have more than 3 books? Right? This map would basically make that report trivial. How many authors have a book that is, for each author, what is the number of books that they've published or they've written, right? All I need to do is go through and instead of printing them out, ask what the length or what the size of that list is, and I'm done, right? So think of ways of manipulating data by getting it into the correct form first, okay? For example, well, okay, I've got this list of authors here, but are the authors in any particular order? Paulson, Crichton, Keyes, Mandel, Pratchett? Is that in any order? No. So what if I wanted an order when I printed it out? I can't do a key set because a set is a set ordered or unordered? Unordered. So it's not something that I can order. So instead, what I'm going to do is I'm going to dump the key set to a list, ... So that's going to be a list of authors, person. And I'll call it sorted authors, is equal to new array list. And I will take the author map.keyset and simply just dump it in there. Right? There we go. Right? Now, this is called a copy constructor. It's a way of giving one collection to another collection so that you can copy the entire collection. Right? And once I've done that, now I can sort it. Collections.sort, sorted authors. There we go. Now, do I need to tell it how to sort? No, remember, I already did the legwork over here by putting in comparable, right? A comes before Z, right? Last name, then comma, first name comparison. So it's all automatic over here. And now I'm going to iterate not over the author key set, but the sorted authors instead. This will give me the final ordering that I want. Who's at the very end now? Not Wells, but Zamyatin. Right? Who's at the very beginning? Douglas Adams, then Alexander, then Anderson, ... Right? Oh, yeah, there's the Black Cauldron series. Right? It's not. It's. Yeah, I guess it's in chronological order reversed. Is that true for all of them? Yeah, it looks like it is because of the way that the other constructor worked. I had probably sorted them that way at some point. Looks like it. So newest to oldest. Right. Okay. Anything else that we want to do with this? Otherwise, when you're doing your assignment 3, make sure that you're thinking about data representation, and efficiency. Man, it would be so easy if it were in this form. And then this report over here would be trivial. Then get it in that form, right? One really quick example would be the patient. Several patients are. A patient is going to be there several times because they've taken several doses. You don't want to double count their blood type, right? Because it'll be A, right? What if I somehow represented the patient and their blood type and then dumped it to a set so that they were only unique, and I didn't have double counting like that? And then I went through and counted up the number of people who had blood type A, B, or C, or AC, whatever they're. I don't know blood types. All right. So think in those terms. All right. Everything that I've just done is a precursor to object-oriented programming, right? To reiterate something that we've looked at before, Java is a class-based object-oriented programming language. That means that the first question you should ask yourself when approaching a problem is, okay, what entities do I need to represent this problem, right? Over here, I wanted to just simply produce these reports on books. Well, a book has an author, which is a person. That leads, semantically, that leads to a natural design, right? Think about your classes for the third exercise. You have patient data, but is patient data one thing? Or is patient data 7 things, I should say, right? The UUID, the first name, last name, blood type, medicine, dose, and date, or something like that, right? So already we've got 7 things, but is it just one thing that I wrap up in patient data? Or is a patient maybe distinct from the dosages that they take, right? Think in those terms. Everything in Java is a class or belongs to a class. And now, more formally here, what is a class in Java? A class allows you to model a real world object or idea or entity. Sometimes we just call them entities in general, right? It allows, or classes allow for strong encapsulation, right? So what is a strong encapsulation? It's 3 things. Can I do this? 1, the grouping of data. There we go. 2, the grouping of behavior, that is methods, functions, functionality, that acts on that data, right? And 3, it is the protection of that data, right? So you are all well familiar with the grouping of data from C, right? If you wanted to do the third exercise in C, what would you end up doing? Probably at least one structure, right? A structure allows you to take multiple pieces of data and, encapsulate them into one thing so that you can deal with that one thing, right? What you don't have in C are these 2 things, though. You don't have the grouping of behavior that acts on that data. We do over here in Java. Let's move this down. So, where is the logic? Where is the code to compare 2 people? Right? Is it located in the book class? No, it is a person thing. So where does it belong? In the person class, right? Where's the logic to format a person's name, last name, concatenated with a comma and a space, and then their first name? Does that belong in random object generator class? No, it's a person thing. So where does it belong? In the person class. Likewise, over here in the book class, right? Everything there is relevant to the book, to representing a book. Consequently, everything that we wrote here, right, is a book thing. Another thing that we could have done is we could have said how old a book is. Public int get age in years, right? To do logic for doing that, right? Dot, 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 right? All you need to do is what? Here, let's just do a quick to do improve this, dot, dot, dot. Because what I'll do is I'll say return 2024 minus this dot year, right? That's going to work for now. In fact, that's going to work for the next 11 months. But is that going to work when we get to 2025? No. What you would want to do is you'd want to get the current date, the year, and then do an offset and do a calculation. But the point is, where does this behavior belong? Where does this functionality belong? It acts on the data in the book class. Therefore, it belongs in the book class. It's a book thing. It belongs in the book class. People things belong in the people class, right? Patient things belong in the patient class, right? However you want to follow that line of logic. Finally, the protection of data. Now, this is something I kind of glossed over when we did the person class. Well, actually, we didn't. Let me show you an example here. I have Terry Pratchett, don't I? Where's Terry? I'll just manipulate him down here. Terry, right? Remember that we created this person called Terry Pratchett. I can go ahead and say his first name is now equal to Terry. Misspelled it in all caps. Does that seem like something I should be able to do? Like, yeah, you generally want to change variables after you've created them, but once I've created an object that represents something, should I go messing with it? It seems kind of iffy, right? We got a question. Would this method of organization be a good match for a buffered reader? Buffered reader would be for if you wanted to read something from a file. And the way you can use a buffered reader for your assignment, but the way that we covered it in class was to use a scanner, right? In fact, let's go over to that now. All right, here's our scanner class. And we inside the scanner class, there's a buffered reader, so you don't have to worry about it, I think. Don't quote me on that. But the scanner is so much easier to use because you can say, does it have the next line? Okay, well, give me the next line. Okay, well, split out the line into the tokens, etc. So yes, you could use a buffered reader, but generally I would use something simpler like a scanner. Right? Anyway, the protection of data. All right, let's go back to the person class there. And again, this book demo, I can go ahead and do whatever I want with this data. That effectively makes that variable into a global variable. And hopefully Hassan said it, quoted it, but there's a nice quote that globals are evil. Why are globals evil? Because if something is a global variable, then that means that everything can access it, everything can change it, and therefore you have to test for the eventuality that anything will change it, right? Now that's absolute chaos. What I want to do is I want to put a lockdown on my data. I don't want you changing this to just anything, right? For example, you could take away their first name entirely. Null. Right? Now anytime I try to do something with concatenation, I'm going to get weird nulls everywhere. Have you ever been on a website that had a glitch of some sort and then it printed null or it printed out code to an end user? Right? Ugly, right? Grandma's not going to understand. What? Null? Do I have to enter null? No, don't do that, right? That's a terrible design. So what we're going to do is we're going to come back over here to the person class, and I'm going to make everything private. Private, private. This is perfectly fine because you can still create a person using the constructor. Give me the last name and the first name. Great. You can still get the first name and the last name if you generate the getters. Right, there we go. Getters and setters. Right. In fact, I'll select all initially here. Right. There's the setters. Where are the getters? Oh, okay, fine. Undo. Generate getters and setters. Where is it? There we go. Select getters, select setters. Okay, fine. There we go. All right, there's set. I selected. Why are you not generating them? This is stupid. Getters and setters. I said All right, I'll manually do this. Everything. You better generate it now. There we go. Now it did it. I don't know why it was glitching there. Let me move this down here and talk about it in a second. Let's instead focus on these two. All right. So this is perfectly fine to make them private because I've given you a way to create the object and I've given you a way to access the first name and the last name. But I have effectively prevented you from directly doing it. I'll allow you to set the first name, this dot first name is equal to first name, provided that it's not null. If first name is not equal to null, then I'll go ahead and let you do that. Right? In other words, the first name is required data. Right? Else, I don't know, throw an exception, new runtime exception. You cannot set the first name of a person to null. There we go. Now an attempt to do that down here, right? Terry.set first name to null will now result in the appropriate error down here. Right? You cannot set the first name of a person to null. It allows me to control data. I wouldn't even do this though. I would get rid of all setters. Right? Why? Because once you've created an object, I do not want you to change it ever. Why? Because it makes it immutable. Remember what immutability is? With strings, once you've created a string, you can never change it. If you want to create a new string, you have to call a function that will manipulate and create a new string for you. Because immutability is a very good thing. It makes it so that everything is thread safe. Right? And we know we are living in a world now where even the simplest of processors is multi-core. And everything is multi-threaded. You are protecting against the eventuality that you've got data here. One thread comes in and is able to read it. Another thread comes in and is able to read it. But what if that first thread starts mucking with it and changing it? Right? Now the second thread has been screwed up. Right? But if your data is read-only, now you can go ahead and read it all you want. Right? A can't change it, so therefore B is fine to do whatever it wants with it. Right? And vice versa. Immutability is a very good thing. And I would never have setters generally for my objects. Sometimes there are mutator functions that are necessary, but those are the exceptions. Right? Only do it if there's a very good reason to do it. Right? Otherwise, everything should generally be private. If you want to go the full 9, you can go ahead and make them final too. That ensures that not even the class can change them. The final keyword is basically a constant. So remember in C, if you wanted to create a constant, const int foo is equal to 10. Right? Const is a keyword in C, right? But we don't have that keyword over here in Java. Instead, it's final. Right? It's the final word. You can never set that again. Right? You can go that far if you want to, but I won't. Let's go ahead and do it the same thing for book over here and see what breaks. Private final. Sure, let's go the full 9 there. Right? So what broke here? Okay, now everything does have to be set. So in other words, it's not going to let you get away with just setting the author. We need to set this.title equal to, well, what's a sensible default? Some book. Is that a good idea? A book? Or just book? What should be a default title of just a generic book? No ideas? So what thing would say this is data is invalid or missing in say C? Null? Right? NULL. Right? We'll go ahead and go with that. All right? Title, ID, also the ID, this.id is equal to null. We can't do that. Actually, I'll show you why here in a second. Right? So what type of variable is the ID? It's a small I int. Small I int, small d double, etc. Those cannot be null. Only the big I integer can be null. So what I'll do is I'll set a sensible default of 0. Right? Okay. What about the ISBN rating and year? This dot ISBN is equal to null. This dot year is equal to 0. Okay, this dot rating is equal to 0.0. Or if you wanted to, you can go ahead and say -1 as a flag value to indicate that nobody has ever rated this book before. Okay. I see a lot of repeated code here, right? And a lot of repeated code here. Is there a way that I could get away without having to repeat that code? Yes, by calling the other constructor. Right? And the way that you do that is with this keyword, but you treat it as a method instead. Right? So 0, what did I pass? Title is null, then the author, then what else? Null for the string, -1.0 for the rating, and 0 for the year. There we go. There, no repeated code. Instead, I just pass off these parameters to this constructor up here, and it takes care of setting everything for me. Right? Don't write lots of code when you don't have to. All right. I just reformatted everything to make it look nice. Right? So that's the protection of data. Okay. Generally speaking, right? Book things belong in the book class, right? Person things belong in the person class. Let me not codize that, right? Etc. Right? You should have one class per entity, right? And model them correctly. Right? Make sure that you are separating things out into what they should be. Protect your classes. Right? It is best to make all variables private, unless you have a very good reason, VGR, for doing otherwise. Okay. So we have all three of those things here: the grouping of data, the grouping of behavior, and the grouping of, and the protection of that data. Generally, look for ways to use composition. Right? So, for example, a book owns an instance of a person, right? The author. Right? In other words, classes can be composed. This is why we call it composition. Composed of other classes, right? And variables. Right? And we did that exact thing with the book over here, right? It had an ID. Well, it also had a string, a string. It had several strings, right? 2 strings right there. Well, what is the string? The string is a class, right? It also had another class, the person class over here. That was composed of two other strings. So if you can have a function that, or you can have a class that is composed of other classes, and those are composed of other classes, and those are composed of other classes. And each one of those is a way of organizing concepts in object-oriented programming, right? Okay, so protect demonstration. Also implicitly, what we've been looking at is objects, right, generally. Now, Java is a class-based object-oriented programming language. There are some programming languages that are object-oriented that do not use classes. For example, early JavaScript. Early JavaScript did not have classes. They had what were called prototypes. Not the same prototypes as C. All right. Instead, if you wanted to create a new class, you basically copied another class. Or a new object, you copied another object. And it's a process called ex nihilo, Latin for from nothing, right? But they realized that that's kind of stupid, right? And the vast majority of object-oriented programming languages use classes, and so later on they added classes to JavaScript, right? So for the most part, all object-oriented programming languages are going to be class-based. You can create a class, define it, use constructors, etc., etc. Right? Now, formally, an object is an entity which is characterized by three things. Identity, an aspect of the object that distinguishes it from all other instances. We did that over here in the person class, remember? We wanted to make sure that all of our authors were unique so that when we put them in this set, we didn't have duplicates of Terry Pratchett. How did we do that? By implementing an equals method. Right? Or we let Eclipse generate the code for us, so we didn't have to write it all. Right? But that is identity. How can you determine that that object and that object are completely different? Right? By default, Java will use the Java virtual machine memory address. So if you create two strings, hello and hello over here, and they're in different memory locations, then it's going to say those are two distinct objects, even though they have the same contents. It is up to you to implement the equals, and by the way, you should also implement the hash code method in order to get uniqueness, in order to get identity. Okay. Identity can come in other forms too. Again, NUID numbers, social security numbers, UUID numbers, right? Or auto-generated database numbers, IDs. You also have state, a collection of properties, elements, attributes, data, field, member variables. We'll usually call them member variables, right? And finally, of course, behavior, the functionality of the object or what it does, or what services it provides, or what functionality it provides. For the most part, what functionality does a book provide? Just a model of a book, right? It's a concept of a book. But you can talk more generally about other behaviors. Right? So it's a little bit different way of looking at functions now, though. Right? It's basically communication between objects. This is done via message sending. You invoke a method, and then the object takes care of everything for you. For example, the one that we've only looked at for now, right? If the only one that we've looked at for now, here's a book class, right? I want to know how old you are, right? What I do is I send a signal to the book class by calling this function. And it says, okay, I'll take care of the logic. I will go ahead and subtract my current year from 2024, and then I'll say, well, I'm a year old, or I'm 2 years old, or whatever, right? It's a message sending kind of approach where you invoke a function, but that function doesn't exist out in the ether like square root in C, right? Instead, it exists inside of a class. So you send a signal to it to start running its program or running its code. Right? Communication is facilitated by the object's interface. When we say interface, we simply mean the public methods that are available. Let me come over here and show you what I mean. All right. We can't do this anymore because Terry is there. So let's just get the first book. Book B is equal to books.get. Let's just get the first book here. Right? And let's go ahead and print it out. System.out.println B. And let's print out its age as well. Right? B.get age in years. Let's run it. What? I'm not compiling here. Oh, I need to change this stuff up here. A.get rating. There we go. That'll resolve that. That'll resolve that. Get rating, get rating, get rating. There we go. Now it should run. There we go. All right, so The Life, the Universe, and Everything by Douglas Adams, published in 1982. So it's 42 years old, right? But now let me go back over here and change the interface so that this is private. It can no longer see that interface. It can no longer see that public method because now it's not a public method, it is a private method. Right? That's what we mean when we say an interface. When all of the public methods that you can invoke on it. Because from the outside world, if you've got this object here, the only way that you can interact with it is by calling its public methods. Right? Otherwise, everything else is what is called hidden. Right? Otherwise, all other aspects of an object are hidden. Right? And this is referred generally to information hiding or abstraction. Right? Information hiding. Right? So let's just go back to C here. So the math library's square root function. Do you know how it works? Anybody looked at the source code for it to see how it works? How does my calculator do a square root function? Do you know? Do what? Okay, so there's probably some numerical iterative method. I would agree. I don't know, but the real answer is who cares? It just works, right? Do you have to worry about that? No. Why? Because it's abstracted away from you, right? Somebody's already done that. Somebody's already put that into a function that you can use. You don't have to worry about those details. They're hiding the information from you so that you don't have to worry about it. They're not hiding it from you so that, this is arcane knowledge that you cannot know. No, you can always open up the source code and find out if you're so interested. And maybe you can also roll your own square root function that has different properties. There are many numerical techniques that get you square root. Taylor series can be used, EDSAC method, iterative division, et cetera, interpolation methods, right? Which one is it? Again, who cares? That's abstraction. I don't want to have to worry about it. Here's another example. Let me go ahead and restore this to public. Over here with the book class, originally I said we only want a year. Right? What if we wanted a full date though? A full date that it was released would it also be what? Private final int month, private final int day. There we go. Now imagine the burden that you just placed on yourself, right? Now how are you going to do how old it is? Now you have to do the days and the months. And by the way, what happens if somebody tries to create something with the 13th month on the 35th day of 2024? Lots of error checking, lots of validation, right? I can tell you that you've probably got 300, 400, 500, maybe 1,000 lines of code to get everything right. Right? Good luck. Or we could not worry about it and let somebody else create the appropriate object and use information hiding and abstraction to do the job for us. So for example, local date, release date. There we go. And let me go ahead and import this. Okay. There is a built-in, and let me take out away private so that it actually compiles there. Release date. How does it work? How does it represent a date? Again, what's the answer? Who cares, right? Whoever wrote this had to care at one point, but we don't have to care. We just use the publicly available interface. So for example, let's just go down here and let me show you. This dot release date dot, oh man, look at all that stuff, right? I can get the month, a day of the month, the day of the year, the day of the week. I can get the era, right? We're in the common era. If it was negative, it would be in the before common era. I could get the month. I could get, I could ask, is it a leap year? Right? That's pretty cool, right? Et cetera, right? So how does all that work? I don't know. I don't care. Abstraction. Information hiding, right? It's hiding how it's representing a date. If you're really interested, by the way, you can jump into it and look at it. There's epoch, days per cycle, whatever. But there's the actual data. What is it? A year, which is an integer. A month, which is a short, which is 2 bytes, right? And a day, which is a short, which is only 2 bytes, because you only need to represent up to 31, or sorry, up to 12 for the month and up to 31 for the day, right? So you don't need a full integer. But what's a problem with that? What happens to when we get to the year 2.147 billion? It's going to break, and we'll be in 2.147 billion BCE, right? So no lessons learned from the Y2K problem, right? Well, we've got a couple billion years to worry about that. Right? But in any case, I wonder what the leap year looks like. Leap year. Find is leap year. Is leap year, I want to find the actual function. Where are you? find Boolean is, actually I can just click on it, there we go. Oh, there it is. All right. Come on. It just goes off to this other class here, is leap year. There we go. Proleptic, whoa. There's a new word for the day. What the heck is a proleptic year? Proleptic year, and then they mask it with 3. Oh wow, that's some complicated logic there. What the heck is a proleptic year? All right, I don't know what is proleptic. Applying the same rule into the far future as far in the past. So in other words, okay, I think I understand now, right? They didn't always have leap years, right? Because, well, they didn't always know that the Earth revolved around the sun. So how could they? Instead, so even though we've only had leap years for the last, centuries or whenever it was established, they didn't have that 3,000, 5,000 years ago, but we'll still apply it 5,000 years ago. Right? I learned. Hopefully, did you learn something new today? Proleptic, applying the same rule far into the future as in the past. All right, you learned your 50-cent word of the day. I did. Cool. Now try to use it in a sentence later on. But otherwise, there are some basics for objects, and we'll pick it up there on Tuesday when we come back. Actually, no, Tuesday. We'll take a break from the main course material because that's usually the time. So next week is your first design document due, the first draft of the design document. No, you don't have to have every section in there. Right? We're only expecting a certain, like the introduction and whatever is responsible for phase 1. We will talk about technical writing on Tuesday in preparation for that document. All right? That document is due not, I guess it'd be what, the 16th? All right. All right. Then we'll pick it up there on Tuesday.